All right, we are ready for a new unit. So we're going to start with our first lesson of Unit 5, which is radicals. So if you look at this picture right here, you have really what a radical is. So you have the symbol, that is just like your square root symbol. You have your radicand, which goes under your square root. And then your radical would be the square root of whatever the radicand is. So that's kind of a lot to think about. So let's do some of these so we understand them. So really a radical is a symbol that means square root. So we're going to go ahead and put square root right in here. Okay? And that's a number that is multiplied by itself to get the radicand. Okay, so this one says we want to find the square root of each number without using a calculator. Okay, so we have to think of two numbers that are multiplied together and they're going to be the same number that equals what's under that radical symbol or that square root symbol. So when I think of 25, two numbers that multiply to 25 that are the same number would be a 5 and a 5. Okay, let's look at number 2. I need two numbers that are multiplied together that equal 81, but the numbers have to be exactly the same. And I know 9 times 9 equals 81. Okay, number 3, when we look at number 3, that's a typo. Let's rewrite that as the square root of 36. Okay, the reason we can't do 32 is there's not two numbers that multiply to 32 that are the same number. So let's change that to a 36. And two numbers that multiply to 36 that are the same number are 6 and 6. Okay? Now we're going to talk about prime factorization, and you need your prime numbers. So please, everybody, write these prime numbers down because these are going to be so important in order for you to do prime factorization. So your prime numbers that we're going to be working with there's a whole lot more than what we're going to write down right now, but these are the ones we're going to be using, are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And we really, for our purposes, we don't need to go any further than that. Okay, we're going to use prime factorization, and we're going to circle pairs. So like when I break things down, or when we break things down, if you have more than one of the same number, you're going to circle those, and that would become a pair. And then pairs are going to come out in front. And when I say in front, that's going to be in front of your radical or in front of your square root as 1. Okay, so your two numbers. So if I had like two 2's, I'm going to circle both those 2's, but I'm going to only write one down out in front. So let's try some of these. Okay, when I'm doing, and I'm going to put my my prime numbers up here just so we can see them. So 2, 3, 5, 7, 11, 13, 17. I'm only going to go to 19 for right now. Okay, so the first thing I want to do is look at that 48. And if I want to break up 48, I'm going to make a little tree like that. Okay, 48 is an even number, so I'm going to start at the beginning of my prime numbers, which is a 2. And because 2 is even, I know a 2 will go into 48. Okay, when I say 2 times what equals 48, or I could say 48 divided by 2, that's going to give me 24. So I'm going to put 24 on the other side. Okay, 2 is a prime number, so we can't break that up anymore. So I'm going to leave that a 2, but 24 is not a prime number. It's an even number. So I know I can take another 2 out of it, and I know 2 times 12 equals 24. Or I can say 24 divided by 2, and I get that 12. Okay, 12 is not part of my prime numbers, so I'm going to break up 12, and it's even again, so I'm going to divide it by 2. 12 divided by 2 is 6. 6 is not one of my prime numbers, so I know I can break that up. It's also an even number, so I'm going to break it up with a 2. 6 divided by 2 is 3. And then when I look, 3 is part of my prime numbers, so I know I can stop. I don't have to go any further because I have found all my prime numbers. Okay, with those prime numbers, now we're going to find our pairs. So I have a pair of 2's right here, and I have a pair of 2's right here. Okay, but then I have this leftover 3 that doesn't have a pair. So out front, this is what we mean by out front. So out front, I have 2, that's going to represent this one right here, times I have another 2, that represents this pair right there. And then under my radical, I have what's left over, and that 3 was the prime number that was left over. Okay, we're not quite done until we simplify what's in front. So 2 times 2 is 4. So I have a 4 with a leftover 3 under my square root. So my answer is going to be 4 square root 3. Okay, let's try number 5. Oh, there it is. Okay, I'm going to go ahead and put your prime numbers up front again so you can see those. So 2, 3, 5, 7, 11, 13, 17, 19. That's as far as we're going to go for that one. Okay, I'm going to start by breaking up my 50. 50 is even, so I want to start with my even number, which is a 2. So I'm going to say 2. If I did 50 divided by 2, I get 25 left. Okay, 25 is an odd number, so I'm going to break it up with one of the odd numbers. The first odd number I'm going to try to break it up with is my 3. So if I did 25 divided by 3, that's going to give me a decimal number. So I don't want to use my 3. So I'm going to look. My next odd number I have is a 5. So if I did 25 divided by 5, that gives me another 5. So I know I can do a 5 and a 5. Okay? And both of those 5s are prime numbers, so I know I can stop because I have all prime numbers at the end of my legs now. Okay, so this 5 makes a pair. Pairs come out up front as 1. So I'm going to put my 1 pair of 5. So this is my pair. It came out as 1, 5. And then I have what's left over. That's a prime number, which is that 2. So I'm going to have 5, and then under my radical is going to be the 2. So I have 5 square root 2 would be the answer for number 5. Okay, let's try number 6. Okay. You don't have to rewrite these prime numbers every time because you have one piece of paper that you can see them on. You might want to write it because now that we're on the back side of the sheet, so you don't have to flip over. So you might want to write these so they're just kind of on the top of your back sheet so you can see them. So 2, 3, 5, 7, 11, 13, 17, 19. Okay, we're going to start like we did before, where I know I have to break up that 96. It's an even number because 6 is even. So I'm going to take 96 divided by 2. And when I take 96 and I divide it by 2, that leaves me with 48. Okay, I know 48 is also even because that 8 is an even number. You always look at your one's place value, and if it is an even number, then your 48 is going to be even. If that place value was an odd number, then I would divide it by that 3. Okay, but 48 is even, so I'm going to do 2, and I get 24. 24 is also even because of that 4, so I'm going to do 2 and 12. 12 is even because of the 2 in the 12, so I'm going to say 2 and 6. 6 is even, so I'm going to say 2 and 3. And 3 is a prime number, so I can stop. So I know now with those, I'm going to find my pairs. So I have a pair of 2's right here and a pair of 2's right here. But then these 2 are not a pair, so I can't circle them, so I'm just going to underline them. That's what's going to go under my radical symbol or my square root symbol. Okay, so this pair of 2's is going to come out in front as that 2. Pairs come out as 1. This pair of 2's is going to come out as another one. We're going to multiply those together in the end. And then I'm going to put under my radical what's left. I have a 2 left and I have a 3 left, so I'm going to multiply those together. So what comes out front gets multiplied, and what's underneath your radical symbol is also multiplied. So I'm not done until I multiply those. So 2 times 2 is 4. And then 2 times 3 is 6. So I get 4 with a square root of 6. So this would be my final answer. Okay, let's move on to number 7. Okay, so I have my 2, 3, 5, 7, 11, 13, 17, 19. Okay, start like I did before. It's 100. It ends in a 0. 0 is considered even. So I'm going to take 100 and I'm going to divide it by the 2, and I get 50. 50 also ends in a 0, so it's even. So I'm going to divide it by 2, and I get 25. Okay, we already did 25, and we realized 25, if you divide it by 3, it's going to be a decimal, so I'm not going to divide it by 3. I'm going to do my next prime number that's odd, because your 5 is an odd number, and that's going to give me 5 and 5. Okay, so now both of those 5s are prime, so I can stop. So I have only prime numbers right here, and I have only prime numbers right there. Okay, so now I'm going to take those, and they're going to come out front. So this set of 2s is coming out as 1, 2. That pair of 2s is coming out as 1, 2. Then I'm going to multiply it by my pair of 5s. Okay, notice that you don't have any other numbers that are prime numbers that are left over. So we're just going to stop right there. We don't have anything we're going to put under a radical. So now I just have to multiply those. 2 times 5 is 10. So my answer to that one would be 10. Okay, let's try number 8. Got those up there. 216. 216's odd, or sorry, not odd. It's even because of that 6. So I'm going to say 2, and if I did 216 divided by 2, I get 108. 108 is even, so I'm going to say 2, and I get 54. 54 is even. I get 2 and 27. Well, 27 is an odd number, so instead of dividing it by 2, I'm going to divide it by 3. So I'm going to say 3 and 9. Okay, 9 is not in my prime number, so I got to keep going. 9 is an odd number, so I'm going to divide it by 3, and I get 3. Okay, now the last number I ended up with is a prime number, so I know I can stop, and I'm going to find pairs. So there's a pair of 2s. Here's a pair of 3s. And here's, oh, hold on a second. That is not a pair of 3s. Hold up. Let's do this. So this was a 3. That was a 3. This is a 3. Okay. So I have this 2 that does not have a pair. So that 2 doesn't have a pair. And then if I look, those 3s make a pair, which leaves this 3 without a pair. They're still prime numbers. That 2 and that 3, they're still prime numbers. So we know we don't have to break them up further. They just don't have a pair. So now I'm going to take what my pairs are. So I have a pair of 2s right here. So that's coming out front as 1, 2. I have a pair of 3s right there. So that's coming out as 1, 3. And then under my radical is going to be what I had left over that was prime but did not have a pair. So I had a 2 that's prime without a pair, and I have a 3 that's prime without a pair. Okay, and we're not done until we simplify that. So 2 times 3 is 6. And then underneath my radical, 2 times 3 is also 6. So I have 6 with a square root of 6. Okay, let's try this last one, number 9. Okay, 24. 24 is an even number, so I'm going to say 2 and 12. 12 is even, so I'm going to say 2 and 6. 6 is even, so I'm going to say 2 and 3. Okay, now I'm at all prime numbers, so I know I can look for my pairs. So I have a pair of 2s right here. And then I have 2 prime numbers that are not pairs, but they are prime, so they have to go under the radical. Okay, so I'm going to start at the beginning. I'm going to take this pair of 2s. They're going to come out as 1. Okay, I don't have any other pairs, so that's the only thing that's going to be outside of the radical. And then under the radical is what's left over that's prime without a pair. So I have a 2 and a 3. Again, you're not done until you simplify. So I have 2 with the square root of 6. Okay. That was a short video today. You guys are lucky. You have everything you need to work on your new, so we're on unit 5 is what we would be on, and it's all about radicals or square roots. So you are ready for your first practice of the new unit.